Okay, in this example, we were asked to find the intercepts and determine the symmetry for the given function. The function we have here is y equals x cubed minus 8x. So we can actually do this in either way, in either order. I'm just going to do it as it's written, find the intercepts. So I'm going to set about first finding my x-intercepts. Remember, to find intercepts, we put 0 in for the other variable and then solve. So for the x-intercept, I'm going to put 0 in for y, and then I need to solve this equation for x. So looking at that, I have x cubed minus 8x. So I realize that I can pull out an x, and that would leave me with x times x squared minus 8, all that equal to 0. Well, at that point, then, since it's factored, now I can't factor x squared minus 8 any further. That is not a difference of perfect squares. So what I can do now, though, is take each thing and set it equal to 0. So on the one hand, I have x equals 0. On the other hand, I'd have x squared minus 8 equals 0, which I'm just going to take one little extra step. Instead of writing that out, and go ahead and move the 8 over to give me x squared equals 8. Now, how do we solve that? Well, we have x squared equal to a number, so we can apply our square root to both sides. Square root of x will be x. Actually, it'll be absolute value, so that's why we bring in the plus or minus. And then with square root of 8, we can break the square root of 8 up as square root of 4 times square root of 2. Square root of 4 would be 2, and then we'd have the square root of 2 left over. So now we've solved to find out the values that make that x would take on that would make y 0. There are actually 3 of them. So that means we actually have 3 x-intercepts. 0, 0, and 0 plus or minus 2 square roots of 2. And then we move to the y-intercept. Y-intercept is much easier in this problem. We would go into our equation here and replace x with 0. Well, if we replace x with 0, then we just get y equals 0. And so therefore, our y-intercept is 0, 0, which is actually shared with one of the x-intercepts. So now we know what the intercepts are, and that's the first part of the problem. We have found the intercepts. Now we want to determine the symmetry. Determine the symmetry. Okay, so towards that end, we have 3 types of symmetry that we need to check for. Symmetry about the x, symmetry about the y, and symmetry about the origin. So we begin first with symmetry about the x. Now remember, the check for symmetry about the x is we want to go into the equation and replace y with its opposite. And then check, is that equation the same as the original? Is it equivalent? Well, the y is wrong. If we tried to switch the y by making it positive, that would change both of these, and so they would be wrong. And it actually should be minus 8x, not x. That's a typo on my part there. That should have been 8x. Okay. And we find out no, right? The answer is no. We don't have that symmetry there. It's not the same. That symmetry is not the same. So no symmetry about the x. So we go check symmetry about the y. Again, for symmetry about the y, we go in and replace x with its opposite. So that'll be negative x cubed minus 8. Remember, for symmetry about the y, we're going to go into our equation and replace x with negative x everywhere it occurs. So that would give me y equals negative x cubed minus 8 times negative x. And then we simplify. Negative x cubed, we can cube the negative. So we get negative x cubed. Negative 8 times negative x will be plus 8x. Once again, if we try to fix the negative signs over here, that would end up messing the y up. So we do not have that symmetry either. Last one we need to check is symmetry about the origin. Now, we can leverage what we've just done, combining our symmetry about the x, symmetry about the y, because symmetry about the origin, we're going to replace both x and y with their negatives. And so that would give me negative y equals negative x cubed plus 8x. And then this time we can multiply by a negative, and it will fix everything because everything is the opposite. And so therefore, yes, we do have symmetry about the origin. Okay, so we know now that we do in fact have this symmetry about the origin. And so there we are. We found our intercepts here, our x-intercepts, our y-intercept, and we have our symmetry this time. Now, of course, it's possible you could have ones where all three symmetries work, and of course you could have ones where none of the three symmetries work, or as we just did here, where just one of them happens.